what I'm saying is that first
There was no male or female.
no there was female and male. It's just the first human didn't come to exist.
Where did the first human come from?
I'm telling you from
thing is,
a
science
common
doesn't give you any
ancestor.
observable evidence for
We
that.
just need to observe, that's what I'm saying.
Oh,
we have to meet your criteria.
But that's,
So you're taking it on belief.
No. It's not unbelief, and I'll explain why. So the way, and again, that's why I'm saying corroborating from multiple sources, because so let's say Darwin came up with this theory, right? He wasn't the first, but he developed it. So he came up with this theory, and then all the guys were like, no, that's bullshit. We'll try to prove it wrong, and they started proving it wrong, and they couldn't find enough evidence to prove it. But then there is genetics, which shows that we share about 90% of the common genes
97% of our DNA.
90% genes, sorry?
with apes.
No, it doesn't.
How much?
Well,
Let's say 90. I went on a limb, but let's say 85.
no. What it basically is that when you're doing a genetic comparison between two organisms,
Yep.
you have to make some assumptions if you're going to say there's a percentage difference between the two. So if I was to ask you, in terms of the human-chimp genome, how much percentage of the human-chimp genome is similar in terms of orphan genes, right? Orphan genes are particular types of genes. Do you know what that percentage is?
Can you explain again?
Okay, you said 90% of the human ape genome was similar.
Yeah.
Now the thing is, whenever you do a comparison between two different genomes, you have to make some assumptions there. There's no such thing as an objective analysis like two books. Like I got one book and I got another book and then I say
80% of the words there.
80%, yeah, you can't actually do that because there's a few assumptions you have to actually make. Now one of the things is, what most people don't know is that the way that they calculate the percentage differences is they look at what's known as biomacromolecules. So they look at DNA or RNA or proteins.
Yes.
Now, depending on what you select and what you leave out, you can come up with various percentages.
So what is your percentage?
Well, I'll give you some percentages, right? If you look at the percentage difference in terms of orphan genes, if you're to look at orphan genes,
Like O-R-F?
orphan, O-R-P-H-A-N.
Okay, like orphan kid?
Orphan kid, yeah.
Okay, we've got orphan genes.
So you got orphan genes. I hope I spelled it right.
And what is it, orphan genes?
Orphan genes are particular types of genes which we have in organisms, right? Now you have an orphan gene in a human being, and you have orphan genes in the great apes. And if you were to do a comparison between the orphan genes, you'd actually come up with 0% homology. 0% difference. But if you were to look at the proteins, you'd come up with 20%. And if you were to look at, say, certain molecules and ignore the rest and say that, okay, do you know what we're going to do is we're going to look at what's similar and we're going to ignore what's different, then you can come up with 99%. But it's very subjective because you're picking and choosing, and according to that, you can come up with whatever percentage. But I'm assuming you believe in human chimp ancestry.
Well, no, okay, let's go back continuing with what you said. So, okay, let's say my number is not correct. Let's say the methodology is not exactly accurate, and
I'm not saying it's not accurate. I'm saying it's based on assumptions. There's a difference.
So let's say, the commonalities is more like 30%.
Okay, no.
Let's go on a limb.
Okay, let's do this. Let's say the commonality is 100%. Okay, commonality is 100%.
But it cannot be because we're different.
Okay, say it's 99.999%.
Okay.
Let's assume that. The fundamental assumption here is that similar genomes means a common ancestor. That's the assumption.
Yeah.
Right?
Yeah.
Now, here are some of the reasons why this assumption is not correct.
Okay, please explain.
We have PAX6 genes, which are for eye development. We have them in fruit flies and we have them in human beings.
Yes.
Yet those are not due to common ancestry. We also have genes for echolocation in bats and genes for echolocation in dolphins, which both code for echolocation, but they're not due to common ancestry. They're known as what? They're not known as homology. They're known as homoplasy. So one of the issues that we have in biology is that we have identical things which exist within the tree of life, which are identical in terms of their genes, which do not have a common ancestor. So the fundamental assumption that similarities equals common ancestry, that assumption is challenged by homoplasy. So I'm not saying it's not accurate, I'm just saying it's based on an assumption.
Okay, so you are saying that the general belief or assertion of scientists that the more we share, the closer we are to a common ancestor is not correct.
According to them, they believe it's an assumption which has some conceptual problems. So they don't use the word "it's not correct." They would say it is a fundamental assumption which has some counterfactuals to it. Like, I'll give you an example. There's a book called Parsimony, Phylogeny and Genomics. It's recently published by Oxford University, and it speaks about basically fundamentally in biology. Sorry, I didn't catch your name. Julian. My name is Suboor. So fundamentally in biology, they assume similarities means common ancestry. That's a fundamental assumption. But then within that book it explains whether we look at the biochemical level or the genetic level or the anatomical level or even the linguistic level or the psychological level, we have what's known as the problem of homoplasy, which is identical features which cannot possibly be due to common descent. So when it comes to common ancestry between human beings and chimpanzees, it's based on a probabilistic framework which has assumptions and which has conceptual problems.
So in that sense, you mean the wing of a bat is very different than a wing of a bird.
Yep.
Although they are the same kind of function, and it's so you would say, according to their hypothesis, or they believe that the more they are together, the more they share a common ancestor. So that for birds and for bats that wouldn't work.
It's not only got to do with birds and bats, it's actually got to do with a fundamental assumption, which is that we assume things which look similar have a common ancestor. That's an assumption. Okay? Now, the problem with that assumption is we know counter examples to that assumption. So all it leaves us with is a probabilistic framework with conceptual problems. The reason why I'm highlighting this is because normally when you watch a documentary, say David Attenborough, right? Or you watch whatever, they just tell you one side of it. They say, look how similar the arm is between the human being and the chimpanzee.
Okay.
But what they don't tell you is, for example, in North America and in South America, they've discovered two saber-toothed cats, right? One's known as a placental saber-toothed cat and one's known as a marsupial saber-toothed cat. Now, the placental saber-toothed cat is closer to a kangaroo than it is to a marsupial saber-toothed cat.
Yes.
Yep. But if you look at their features, if you see a kangaroo and you see a placental saber-toothed cat and you see a marsupial saber-toothed cat, based on anatomical features, you would say these two cats have a common ancestor.
Yeah, but I don't know if that is the way to judge it, because fish and whales, right? They do have more commonalities than whale and a what is it? Hippo, right?
Yep.
But they are different species, so the commonalities is not a way to judge the same ancestor, because it's the adaptation in this case, right? So let me phrase it in maybe a more coherent way.
Sure.
Fish and whales seem to be very close to each other, although they have different ancestors. But it's because they adapted to the same world that they have the same features.
Okay,
so that sense, what you're bringing with the northern cat, or and the marsupial cat, that's
okay,
why it would have the same ancestor but they have adapted to the same kind of world, and that's why they have similar features.
Yeah. Now that's known as convergent evolution, right?
Okay.
Now convergent evolution is a term that scientists give when they come across something which cannot be due to homoplasy, which cannot be due to common ancestry. But something which is very, very important is to understand that there is a distinction, because remember, Darwin didn't actually come up with this stuff that we're speaking about now.
Yeah, he developed it, but
right.
He wasn't the first one, yeah.
What it basically is this: Darwinian theory is not a theory of similarity. Okay? So what we're speaking about now is not even Darwinism. What we're speaking about now is what's known as homology, which was an idea which actually went back to the ancient Indians, the ancient Brahmins, about 3,000 years ago, the ancient Hindus. They looked at a human being and a chimpanzee, and because they were naturalists, they believe in nature. They didn't believe like in a metaphysical creator creating everything. Well, some of them did, but not these particular ones. So what they basically said is, look how similar a human being is, look how similar a chimpanzee is, therefore it has a common ancestor.
Okay.
But that fundamental assumption went down to the Greeks, Pythagoras and to the ancient Greeks. Then it went down to the Enlightenment period, and Erasmus Darwin, who was Charles Darwin's grandfather, he was basically a Freemason, right? And the Freemasons, he was a 33-degree Freemason, and the Freemasons, they have this sort of thing where they want to go against religion. They want to rebel against religion, and they needed a naturalistic philosophy.
But I thought the Masons are. You have to actually believe something to be a part of it. So how are you? You actually? That's what I heard. And correct me if I'm wrong. To actually be a member of it, you actually have to believe, and it doesn't matter what God is it. You have to believe. So then, that's kind of doesn't make any sense.
The Freemasons were against religion. They were secularists.
Yeah, but then the criteria for you to join is to be religious.
Okay, I don't know the criteria to join.
But I can tell you that.
I'm not sure about the criteria to join. But what is important is where I was trying to get to, which is when Darwin came along, Darwin didn't come up with the idea of homology, what we're speaking about now. What he came up with was a solution to a problem.
Yep.
Because you know when you have that great marching band, you have a small knuckle-walking chimp-like, Lucy-like fossil becoming into a bipedal ape, right?
Yeah.
Now, for that trajectory to work, you need natural selection, you need a mechanism, right?
Yep.
So all Darwin did is he came up with a theory of natural selection to explain how you can get from that chimpanzee-like creature to a human being. So let's leave similarity aside, because if we're going to speak about Darwinian evolution, we have to speak about, does this natural selection mechanism lead this to that? Okay. Because if you don't have that, all the similarities in the world are pointless.
Okay.
Do you understand my point though?
Yeah, so you're saying if when we use Darwinian evolution,
Yep.
we have to prove that from these species we can get to this species.
No, you have to show that the mechanism to get from this is this, right?
Oh, okay.
Because I could be very similar to something in nature, but if there's no trajectory from X to Y, then all I have is a story.
But there is some missing part, like, you know...
Sorry, let me just finish this conversation first.
It is in his conversation. There is appendix, you know, it is one of the organ inside our body.
Yep.
What is the function of this small, teeny tiny